We generally envision the universe as a grand, empty theater. In this classical view, space and time form a passive stage, providing a backdrop for stars, planets, and subatomic particles to perform their roles. This model collapses when we look at the fine details. The mathematics of atoms refuses to align with the pull of gravity, and our best theories still lack a proven mechanism to explain why time appears to move in only one direction. The universe also exhibits an unexpected preference for order. While the second law of thermodynamics predicts a drift toward total chaos, cosmic matter consistently clusters into high-symmetry galaxies and stable atomic orbitals. This drive toward organized, low-information states suggests a governing logic that a simple physical vacuum cannot account for. Physicists are now exploring the possibility that space, time, and gravity function as emergent software rather than a physical stage. This framework treats information as the foundational building block of the universe, suggesting that physical matter is the secondary result of data organization. Under this model, the laws of physics represent the execution of a cosmic optimization code, constantly refining the state of the system. This system begins with a base layer of quantum states. It operates like a vast quantum neural network, processing parallel possibilities and entangled probabilities across the entire network. This is supported by the second law of infodynamics, which states that a computational universe must continually seek to decrease its information entropy. To maintain stability, the system is designed to minimize the amount of complex data it must process at any given time. Calculating the individual coordinates, velocities, and quantum states for trillions of scattered particles requires a massive allocation of processing power. The universe resolves this through data compression, zipping scattered information into organized structures. As illustrated, tracking a single compressed planet requires a fraction of the data needed to compute billions of separate pieces of debris. This shift minimizes total information entropy. We experience this optimization as gravity. The gravitational attraction we observe is an entropic algorithm running in the background, designed to condense information and prevent a system-wide processing overload. For this compressed data to evolve into complex structures, the universal processor requires a clock to sequence every event and interaction. A single linear timeline lacks the depth required to process quantum probabilities and galactic evolution simultaneously. Instead, the math requires a three-dimensional framework for time itself. These three temporal axes emerge from symmetry requirements to manage different scales of reality. The T1 axis functions as the quantum scale clock, governing particle behavior. The T2 axis mediates quantum classical interactions, while the T3 axis drives macroscopic changes like galactic evolution and gravitational waves. Time serves as an active three-dimensional operating system generated by the universe to synchronize these overlapping streams of data. This suggests that physical matter is a manifestation of temporal curvature. Structures exist only because of the way time and information interact. Our everyday perception acts as a user interface. Human beings see a simplified, rendered output of the universe's deep computational processes. An apple falling from a tree follows a data compression mandate. It moves toward the Earth to lower the local information entropy of the system. The steady progression of minutes on a watch represents a localized shadow of the underlying multidimensional timeline. These familiar sights are the desktop icons of a cosmic optimization engine. Reality emerges from information, while time acts as the shadow cast by that data as it organizes itself into existence. Subscribe and join us for the next episode as we continue to decode the universal source code.